Welcome to another Peterson podcast. In today's podcast, I want to talk a little bit about slope and cooling rate and help you solve for slope using the data that we've been collecting this week on our lab. So what you're looking at is this is the example of the data that we collected Wednesday on the cooling rate lab. And what I want to do when it comes time for me to start analyzing this information is start looking at the differences between these. Now, it's real obvious in the control, which was the bag that had the variable left out, so that bag had no insulation in it, that I had a very dramatic cooling rate and it cooled off quite significantly. But it becomes a lot harder when it comes time for me to compare these other variables, the feathers, the fat, the fur. These lines don't have as dramatic a change. And so the way to be able to compare these then is to calculate the slope of each of these lines. Basically, slope, remember, is rise over run. And so another way of looking at that with regard to this data is the change in temperature divided by the change in time. And so you can see I have time column right here and my temperature column right here. So the formula for this is going to be y2 minus y1 divided by x2 minus x1. And so when I go back to my data, I use this as the beginning temperature and these as my ending temperature. So for example, if I were to look at, I think this one is, yes, the control. If I were to look at the control, it had an ending temperature of 11.9 degrees Celsius and a beginning temperature of 70.4 degrees Celsius. And I divide that by 10 minutes. I went for 10 minutes but started at 0. So then I do the math here, and this becomes negative 58.5 divided by 10 equals negative 5.85 degrees Celsius per minute. So basically what that means is when I go back to my data, this line right here was cooling at about 6 degrees Celsius per minute. And I would do that with each of these other lines by using the beginning temperature minus the ending temperature in order to find out what exactly the slope is of those lines. So for example, this is the example I have on my web page. You can see here that it becomes real easy for me to see that the feathers right here had the smallest cooling rate or had the best insulation. And I can then use that information in my conclusion here to prove whether my hypothesis was correct or incorrect. So again, that's a really good way of helping you as far as calculating the slope of each of those lines. I hope this was helpful. Good luck.